Okay, so in this video we're going to look at integration by substitution. So as always, let's start with a definition. So the integral of some function of x with respect to x can be given by the integral of that same function f of x divided by a substituted du dx with respect to u. For now, this formula won't seem entirely obvious as to what's going on. It's basically attempting to substitute a u value for an x value to simplify the equation. So let's take a look at one example. So if we consider the integral of 3x squared multiplied by x cubed plus 5 with respect to x, we can hopefully see that 3x squared is the derivative of x cubed plus 5. And that means we can apply some substitutions. So if we choose our u value to be equal to x cubed plus 5, if we take its derivative with respect to x, that gives us du by dx is equal to 3x squared. And this in turn means that dx is equal to du over 3x squared. So if we now take our u value and substitute it here, and our dx value and substitute it here, it should give us an integral in terms of u. So this expression becomes the integral, and 3x squared remains where it is, but now instead of the x cubed plus 5 we have u, and instead of dx we have du over 3x squared. And now very obviously these 3x squared values directly cancel each other out. So we're left with an integral in terms of our substituted value u du. Now very simply, if we solve this, we increase the power by 1 and divide by the new power, and as always with indefinite integrals we need a constant of integration, and then all that's left to do is replace our u value here with what we had before, which gives us a final solution of x cubed plus 5 all squared, that's u squared, over 2 plus c. So for u substitution to work, what we needed inside the integral was a function multiplied by the derivative of its function. Let's take a look at another example. So in our second example, we're asked to evaluate the integral of x multiplied by 5x squared minus 7, all square rooted, with respect to x. So first off, it's very important to notice that the derivative of 5x squared is equal to, or is related to in some form, to x. And it's these conditions that are required in order for us to use integration by substitution. So since 5x squared minus 7 can be differentiated to give us some term in x, we can use the u substitution. U is equal to 5x squared minus 7. And again, if we take the derivative of this, we have du with respect to x is given by 10x. So that means again that we can find that dx is equal to du divided by 10x. So let's apply our substitutions now. So we have now the integral of x multiplied by the square root of u, which is the same thing as u to the 1/2 power. And our dx can be replaced again by du divided by 10x. And as in the previous example, we can see that the x will cancel with the first x here. And since 1/10 is a constant, we know we can pull it outside the front of the integral, like we saw in the previous video. So we now have from our substituted values, this now looks much simpler than it did at first. So let's integrate this. So the 1/10 still remains where it is. And the reverse power rule says that we need to increase the power by 1. So u to the 3/2 power. And then we need to divide by the new power. So we divide by 3/2. And, as always, in indefinite integrals, we need a plus c, a constant of integration. So now all we need to do is resubstitute our u values. So finally we have, and since we have a fraction on the bottom, we can flip this upside down and multiply. So we have 2/3 multiplied by 1/10. So that's 2/30ths, which is 1/15. So 1/15. And our u value is 5x squared minus 7. Remembering again to the 3/2 power plus our constant of integration. And there we have our final solution. So by realizing that inside of your integral sign you have some function multiplied by the derivative in some way of the same function, then it's possible to use integration by substitution to simplify it significantly. So step 1 was to pick a u value which is differentiable in x related to what's inside our integral. And secondly, we calculated what dx is in our new terms. And then we replaced our original function, simplified, and solved. Let's now take a look at an even more complicated example. So in this example, we're asked to evaluate the integral of the exponential function e to the 3x divided by e to the 3x plus 2 with respect to x. And it might not be initially very obvious that we can use integration by substitution in this example. However, we know that the derivative of e to the 3x plus 2 is related to e to the 3x in some way. So let's pick our u values. If we say that u is equal to e to the 3x plus 2, then our du value by dx is equal to, if we differentiate this with respect to x, we have, using the chain rule, we have 3e to the 3x. So this means that dx in this example must be equal to du divided by 3e to the 3x. So now let's apply our substitutions. This gives us the integral of e to the 3x divided by u, and dx is now du over 3e to the 3x. So we have du over 3e to the 3x. And once again we can see that this e to the 3x value here will cancel with this one. And our 1/3 value, being a constant, can be brought outside of the integral. So now we have 1/3 multiplied by the integral of du over u. And we can directly integrate this. So we know that the natural log of u differentiates to 1 over u. So that must mean that the integral of 1 over u integrates to the natural log of u. So we then have, not forgetting the third of course, the third times the natural log of u. And as always, plus our constant, because we have an indefinite integral. So now let's reapply our u value. So to conclude, we have 1/3 times the natural log of e to the 3x plus 2 plus our constant of integration c. And that's our solution. So by using integration by substitution, we've gone from a very horrible looking integral to something that looked very simple. And all we needed to identify was that we had a function multiplied by the derivative of that same function to some power. So hopefully this video has helped you understand integration by substitution. In the next video we're going to take another important method when it comes to integration, that's integration by parts. As always, if there are any questions, feel free to pop them in the comments box below. See you in the next video.